It's Nickel Mickle, and I have another project that I want to share with you guys. It's basically a bonus project that I did for my class. It's about population and how a population gets infected. So you have like this txt file for population, the specific txt file, the period, and patient 0. So it goes to, okay, this is population 1 txt for it. That's basically a matrix of the people, and then the infected in the infection ID. And to get the output, it goes like this. You just type it in, prints out the adjacency list, the cluster of people and how many people each cluster had, prints out that list and the average degree. Then it has simulation to see how long it takes for someone to get infected and then recovered. And then a bonus thing I included was entered how long it takes for one person to be infected by the infected person if they're in the same cluster. So I'll show you my big code. We have adjacency file, latent period, infected period identity. Then we have the additional info of nums, clusters, people in cluster, cluster degree, degree in people. We have entering the file. We have the thing that reads the file. It gets the adjacency file after the first colon as seen here. Then it goes to the infection period, and then identity, which is based on here. And then it runs the simulation, tries to determine it's trying to determine who's viable to be infected or recovered. There are a lot of for loops and if statements in this. We have to make this, and they have to make the basically sets the infection and makes accessible the remainder of infected and recovered. It's going to print out each component and then how many days it took for the outbreak to end. Going back up here for adjacency list, reads all that, makes that list of the numbers in the matrix based on the colon, has to print all that out. We have a thing called count clusters, needs to count how many clusters there are with a depth first search. Depth first search basically release two. Depth first search basically has a Boolean array list, and then it gets the specific person that's going to add the degree based on that special index. And then for each number in that list, listed by the index, it's going to set, as long as it's not been visited, it's going to add that in a recursive depth first function, and it's going to return the people's value. For count clusters, it's going to use depth first search to make the number for the people in cluster. That's going to be added to the array list of that, and the degree is going to be added to the cluster degree. Meanwhile, for each one, clusters increments, and then it just returns that. Goes down here, prints the average degree, has to do that in the for loop. It has to print out all those people too. And once again, there's like a lot in the simulation. Has to determine whether each index is infected and not recovered, and as long as the days of sick is more than 0. Then next time, if it's not recovered or not infected, not infected, it turns to true. You have single for loops for like if it's infected, add 1 to day sick on that one. If the day sick is greater than the affected period, then it's going to go to true. And another one, if it's infected and not recovered, it turns infected goes up 1. Else, if it's recover goes up 1. I already said the remainder of this stuff. Okay, infection connection, this is the bonus. I have queues of integers, then you have to enter the ID the starting person. You have to, and then you have to print the idea. You have to, okay, get the IDs of starting person and target person. Then we have another Boolean array. Then we have a Boolean to match it. It starts adding we start adding defaults to each queue, one for next visitors, one for next steps. Then while the queue next visitor is not empty, we gotta make the current steps value. It's gonna take that and then take the first part of each array and then remove it. And if the current matches the affected person, it's gonna say as a match, and it's gonna show how many steps it's gonna take. Current steps would thus increment, and for each loop on that special num and that specific array list made by the nums double array list, if it's not visited, it's going to set it to true, and then queue is going to add next step and the next visitors. If it's not matching on the same cluster, it's going to say that. Okay, now let's run this. Okay, we got the adjacency list. Just compare it to population 1. Yeah, it prints out properly. Then we print all this simulation, and then we'll make a ID of a starting person. Let's say 3, target person 5. It would take 2 days for person 5 to be infected from person 3. Again, this project was really complicated. It's hard to explain off the top of my head, but I'll scroll down one more time so you guys can get the gist. We have basically a thing that enters the file, reads the adjacency list, a thing that makes the simulation. Yeah, we could see how it takes that time to make the simulation, how it goes from infected to recovered. Depth first search, count clusters is what my custom variables were. Needed to go down. And finally, infection connection, the bonus thing that I had. This was a tough project, and I hope I enlightened you some way, because sometimes the chaos is what helps. See you around.